Hello, everyone. My name is Amitai Richman with K2view. Welcome to this webinar titled Test Data Management, Separating Fact from Fiction. I'm here with Daniel Howard, Senior Analyst at Bloor Research. Very glad you're here, Daniel. It's great to be with you. And I'd love it if you can introduce yourself and your company, please.
Thanks, Amitai. Very happy to be here today. As you say, I'm Daniel Howard, a Senior Analyst at Bloor Research. Bloor itself has been around for about 25 plus years now, since the 90s. Since then, we've been providing, as you can see on the slide, impartial, independent, and expert opinions to help vendors and customers navigate today's technology landscape. I know that's a bit of a mouthful, but it really does sum up sort of what we do and what our mission statement is. As for me personally, I've been working at Bloor for about 8 years now, doing analyst work across a variety of data spaces, not least of which is the subject of our talk today, test data management.
Great, thank you, Daniel. So let me introduce K2view, but first I'll just introduce myself. So my name is Amitai Richman. I'm responsible for test data management, data masking, and synthetic data generation, and data tokenization at K2view on the product marketing side. And so let's talk about K2view in a few sentences. So K2view is a data product platform that is capable of integrating and connecting to any data source. And we are fortunate to be covered by a number of different analysts, such as Bloor and Gartner and others. And as I mentioned, we have different solutions, including we're here today to talk about test data management. So we're going to cover 6 different myths that we believe are prevalent in the market. And we're also going to talk about some trends in the industry at the end. So let's just name and list off the 6 myths we're going to debunk today. So the first myth is that self-service is a GUI. Daniel will talk about that, and he'll also talk about synthetic data and about privacy, regulatory compliance. And then I'm going to talk about test data management, return on investment, how ephemeral it is, and how quantifiable it is. And we're going to talk about data masking, whether it's a commodity or not, and other things related to data masking. And then we're going to talk about the relationship between test data management and data virtualization. So without further ado, let's jump into it. Daniel, if you can please kick us off.
I'd be very happy to, Amitai. So the first myth we're going to talk about today is to do with self-service. Specifically, the myth, self-service is essentially a fancy term for providing a GUI, which is, say, a graphical user interface. And obviously, this is not true. A GUI, while it may be a requirement for most, if not all, self-service technologies, is not in itself sufficient to provide self-service. The reality is that self-service is a distinct and particular capability over and above just providing a GUI. To reiterate, a GUI alone really is not sufficient to be able to provide self-service, at least not effective self-service. The core of self-service, in fact, and in self-service in general even, and self-service test data in particular, is to empower your testers and developers to provision test data, the test data that they need, without requiring DBAs or data engineers to be a part of that provisioning process. The reason for this is that you really need, I'm going to talk a bit about this more. I'm going to talk about this a little more on the next slide. The short answer is that you don't want to you can't over-centralize your DBAs and your data engineers, or you can produce these really horrible bottlenecks, and it creates this very long lag time before you can retrieve your test data. So to get around this, you need to remove DBAs and data engineers from the process. And in order to do that, you need a variety of automated provisioning features. So that when your tester goes to retrieve their test data, the process can simply flow smoothly from there, since you can't expect a tester to necessarily do a DBA's job. You also are going to want collaboration features, or at least they're going to be helpful, in order to prevent things like testers provisioning the same data and stepping on each other's toes in that sense. And so to elaborate a bit about this a bit more, why is this so important in the first place? Well, as I said, the problem is that by over-centralizing your test data provisioning, you create these really horrible bottlenecks around your data engineers and DBAs, where you have too many testing teams, too many testers and developers requesting test data at once, on top of the DBA's other responsibilities. You create these extremely long lag times, which most people I think will be familiar with if they've worked in testing, where you request test data and you're waiting often, sometimes only hours, but often days, weeks, or even months before you get your test data back to you. And this is obviously an intensely long time to wait, which really slows down the testing process. And in particular, if you think about modern, particularly agile software development, your sprint lasts 2 weeks. Often the goal of all this stuff is to do in-sprint testing and to test in an agile fashion, testing every 2-week period and so on. If it's taking you 6 weeks to get a set of test data, there's no way you're going to be able to do that. So you really need to address these bottlenecks and let people provision test data themselves, rather let your testers provision test data themselves.
Yeah, Daniel, if I could jump in for a moment, please.
Yeah, please do.
So 2 things. First of all, I think when people talk about self-service in the context of TDM, so they typically are thinking about the data engineers, the DBAs, the ones that are responsible for test data provisioning, as you mentioned. And so the distinction that you're making and that we want to make is that when you hear the term self-service in the context of test data management, it's important to clarify and to ask, self-service for who? For which person? Is it self-service for the data engineer, for the IT team responsible for provisioning test data, or is it self-service for the testers or developers that are actually consuming the test data? So that's the first thing I wanted to mention. The second thing is, I like how you bring the range from hours, days, weeks, and months. We've heard at K2view hours is very unusual to hear that estimate. That's a really optimistic scenario in our experience. But whether it's days, weeks, or months, oftentimes depends on whether there is a tool in place.
Absolutely.
So if there is no test data management tooling we're working with enterprises, so oftentimes they have complex data networks, different data sources, and all of this takes time to extract data from different places and prepare it in the right format, etc. But the length of time, first of all, depends on whether they have a tool or not. But the point, going back to the first point, even if they have a tool, it's still, as you described, a process where a tester needs to submit a request for test data and then wait for it to arrive. And how long that takes can vary from place to place, as you say.
Yeah, well said. I think the key point here is to, as I said before, empower testers be able to get about test data themselves without needing to go through any other people, in effect, just automated and provided processes. And I think realistically, that's the only way you're going to let your test at a rate that keeps up with broader software delivery. So moving on to the second myth, which is to do with synthetic data. The myth is the idea that synthetic data is a silver bullet solution for test data management, but it is the best method and the only method you need for managing your test data. And while I'm not going to deny the reality that synthetic data is a powerful tool, it is only a tool. And like any tool, it is not suited for every use case. It is certainly not always ideal. Just to begin with, there are simply no silver bullet solutions. As I say, any tool has its pros and cons. And while synthetic data can be particularly powerful in, for example, a greenfield context where there's no production data already available, and therefore generating data from whole cloth is effectively the only way you're going to be able to get test data, There are other use cases where other methods, subsetting, for example, is just as, if not more useful. And thinking about a test data management solution as a whole, the more options you have access to, the more effective options, the better. If you've got synthetic data generation and subsetting, and they're both to a good standard, you're always going to be better off than if you just have synthetic data, simply because you can deploy both of those solutions when they're most appropriate.
Daniel, while you pause for a moment, I just want to mention a quick housekeeping point. We've seen a few questions coming in, which is great. I want to encourage everyone listening live to please submit your questions, any questions that you have, and we'll get to them time permitting at the end of the session. Please continue.
Thanks, Amitai. So following on from that, I thought I'd take a brief aside to talk a bit about how synthetic data is created, because I think because the answer is not particularly simple. I think a lot of people are sort of in the dark on this topic. Because ultimately it does depend on which solution you're talking about. Everyone does it slightly differently. That said, there are two, I think, broad strains of synthetic data generation solutions. On the one hand, you have, and I'll talk a bit about these in more detail over the next couple of slides, you have rules-based solutions for generating synthetic data, where you create a bunch of rule-based constraints and use those to create your data based on them. And then you have a sort of more analytical approach where you quantify the patterns and properties of your existing production data and then use those to generate imitation data sets, in effect. But regardless, they both have the advantage that the data sets you create can't contain sensitive data because there's no way for it to make its way in there. It's not like a mass subset where you're starting with sensitive data and then protecting ideally all of the sensitive data there. There is simply no sensitive data whatsoever. And that really can't be overstated as an advantage, even if it's not always practical to use. So the first of those methods, to sort of elaborate on this point a bit more, is a rules-based method. So the idea here is that you'll have a series of rules which you will need to create, which will specify the constraints of your test data. So for example, if you're creating test data for a customer, you would have rules saying they're going to have the first name, which is so many characters long, and it's from this list of names or what have you. We're going to have a last name. Similarly, we're going to have an address, maybe address in a particular area. They're going to have a date of birth, maybe a date of birth, which is at least 18 years prior to the current date or something like that, if you want to constrain based on age, what have you. You're going to have a bunch of these rules you're going to create for the data set you want to make, and then it's going to create data sets within the ranges you specified, in effect. And the problem, I should say, the biggest problem this faces is that it can be quite a lot of effort to create all of these rules, right? Especially if you want to do it for multiple test data sets, imitating multiple different kinds of data and so on. Occasionally, you will have solutions which will provide some of these rules up front as a sort of default capacity, and then you need to customize them. More often, you need to create them all from whole cloth. And while this does have a massive advantage of not requiring any production data, you just need to specify what you want it to look like. It is also quite a lot of effort, and as I say, it's quite manual. It does provide a lot of fine-grained control over the data. If you want to include a specific test scenario, you can make sure that's included. You have a high degree of control over the makeup of your synthetic data sets, at least on this sort of granular level, even if not in terms of their overall makeup. The other factor about this is that it's quite common. Most solutions which are not dedicated synthetic data solutions, or which have not invested a significant amount of time into their synthetic data generation capabilities, offer this kind of rules-based approach. And it's not, which isn't to say it's bad so much as that it's relatively straightforward.
Yeah, Daniel, I just want to share that a common use case we see for rules-based synthetic data generation is, for example, when we have a customer who is developing new functionality or a new feature for an app for something that doesn't exist in production. So for things, some of our banking clients, for example, let's say they have a stock portfolio and it covers stocks and ETFs and the like. Now they want to introduce cryptocurrency. So there's no cryptocurrency transaction data in the production database because it's a major new release. So in order to test the app ahead of time, so they need to manufacture that and use. This is really the method to use to create that synthetic data that you need. And as you say, it is a little bit time consuming, sometimes very time consuming, depending on how complex the data set is. But that's a good use case for that.
Yeah, absolutely. As I say, anytime when you need in a greenfield environment like that, where you don't have production data to work from, this is far and away the best way of creating test data. Arguably, it's the only way of creating test data with any level of sophistication at all. On the other hand, you also have, as I say, this kind of representational analysis you can do to create synthetic data. Where the idea is that you take a production set. So this wouldn't work quite so well for those greenfield environments we've just been talking about. But for other environments where you have a production data, the idea is that you analyze your production data sets, detect any sort of statistical properties and patterns and so on, and replicate them in your synthetic data set to create data that is, sometimes described as realistic but not real, for example. The other phrase which is commonly used is retaining statistical integrity. But the statistical properties are always carried over into your synthetic data set. And the advantage of this is that it's very automated, because it's practically impossible to do this manually for obvious reasons. This needs to be an automated process. Usually, it leverages machine learning or other forms of AI. In recent years, this has often been done using generative AI, which is certainly seen some success in the market at the moment. And the other big advantage is that, as I say, you're creating a synthetic data set, so it's inherently not containing sensitive data, which maintains statistical properties in the data set. That's important for what you want to use it for. That's great. But as I say, you have to have production data to begin with, so it's not much use in greenfield environments. You don't have that much control over the data you create. You can, of course, manipulate it after it's been created. You don't have the sort of inbuilt fine-grained control with a rules-based approach does. And finally, this is a relatively unusual capability to provide due to the level of sophistication it requires, usually in terms of things like AI and statistical analysis and so on. So it can be a little bit trickier to get a hold of, but it can be very valuable.
Okay, great.
Sorry, last slide before you go. I wanted to pass over to Amitai, who has a few things to say about synthetic data as well.
Yes, thank you, Daniel. So, as Daniel said, synthetic data generation is a very important component of a TDM strategy, especially for dealing with new technologies, new features, new changes to the schema, as we mentioned. But it's a feature, right? Test data management is a big methodology and a practice, and synthetic data generation has an important part of it. But we have to remember it's still a very young, immature technology that's only penetrated a small part of the potential total addressable market. And the technology is constantly evolving and improving. It requires a lot of work, and as Daniel mentioned, the pros and cons to the different approaches. But beyond the different approaches, there are also elements related to test data that are not covered by a synthetic data generation tool. For example, moving data from one place to another, from one environment to another, specific testing challenges that QA people face every day, which I'm going to dive into briefly here. So, for example, if subsetting test data is a very basic functionality of a TDM solution, right? We think about it as a very obvious thing. But imagine if you want to subset, every time you want to create a different subset for a different test scenario, you need to create a new synthetically generated data set. That's a big ask, and not so easily done. And when you're blending data from different data sources, this can be a technical challenge to build the right data set. And of course, as Daniel mentioned before, you want to make sure that you're ensuring referential integrity. There are parent-child relationships to keep in mind. Obviously, you don't invoice a customer before a customer was created. All kinds of time constraints that need to be taken into account. And you want to make sure that even if you've created a data set, doesn't matter if it's synthetically or not, you want to make sure that testers are not overriding each other's data, so that they don't have to go back to the drawing board and do it again. So to summarize, synthetic data generation is great. Definitely an important part for a test data management solution, but there are some challenges and pitfalls to be aware of. So the complex data relationships, potential inaccuracies, the AI, ML that Daniel mentioned, sometimes can create things that don't make sense. For example, time-sensitive information. And it's a very time-consuming task. So let me hand it back over to you, Daniel, please, for our next myth.
Yeah, thanks, Amitai. And just to comment on all the things you've just said about synthetic data, I think it just really reinforces what I said at the start, that you really want a multivariate approach here. Synthetic data is great, but you probably want to be using other things at the same time, and not use any one method exclusively.
Great.
So moving on to the last myth that I'm going to leave you with before Amitai will go through the last three, is that compliance is a uniform concept. This is the idea that there is a universal compliance mandate that you need to apply uniformly across your entire organization, and that's the beginning and end of compliance. And this is, of course, not true. The reality is that compliance is incredibly diverse and only growing more so. There are compliance mandates that differ either minutely or really very substantially all across the world. You have things like the GDPR in Europe, of course. You have the CCPA in California. You have the LGBT in Brazil. You have acts in Japan and New Zealand and Thailand. All sorts of different places internationally that, while broadly doing the same thing, differ in the details in a way that matters when it comes to compliance if you're operating in those regions. Both in terms of what kind of data you need to protect and how you have to protect it, what you need to actually do with it. So what often this is not going to be a universal thing for your entire organization. It is very likely, if you are an international organization, even if you're a national one, you're going to have different parts of your organization falling under different compliance mandates, which may even sometimes contradict each other. And what's more, these regulations are not staying still. They're going to be changing and growing, and new regulations will come up in the coming years. So you need a solution that is that is dynamic, that you can change, that is able to keep up with this changing compliance world, both in test data management specifically and for more general data governance. So here I've got a map of ultimately a fairly small selection of data privacy laws across the globe. And this contains several of the ones I've already mentioned, GDPR and LGPD and so on. But just to use a leading example here, imagine you're a company that lives in America. Your headquarters are there, you operate out of California, maybe you're Silicon Valley. But you're still, most likely, you're an enterprise, you've created some success for yourself. You've got offices in Europe, you've got European customers, you've got offices and customers in Asia, Australasia, Australia, New Zealand, and so on, Brazil, South Africa. you're going to have to deal with all of these different compliance mandates for the data you take in on those customers specifically. You're probably going to want to store that data locally because most of these regulations have some fairly significant constraints on moving data out of where you collected it. And you're overall going to need a very complex and multitudinous way of examining your compliance and figuring out how to comply with all these regulations, both in terms of, as I say, data as a whole and test data in specific. Because you're going to want to take a lot of that production data and use it to create test data sets. You need to be able to know exactly what you can do and what you have to do with that data when you want to turn it into test data. I hope that it makes things a little more clear. It's obviously a very complex topic, but I don't have time to go into a lot more detail here now.
Yeah, and plus we have also the industry-specific standards like PCI DSS for the financial services industry and HIPAA for the healthcare industry. So we've got to take those into account as well, obviously.
Yeah, of course, Amitai. Yes, yeah. The regulations on this slide are only the generic ones which apply to personal data as a whole, or sensitive data, whatever they call it. Of course, you've also got, as Amitai says, industry regulations like HIPAA and PCI DSS, which will apply in addition to all of this stuff and can also be regional. So basically, it's an incredibly difficult and thorny topic. To say, we can't realistically go into much more detail here, but it's very important to be aware of. I believe with that, I will pass over to you, Amitai, to talk about the ROI of TDM and
Thank you.
It.
Thank you, Daniel. We'll come back to you a bit later to talk about future trends in the industry, and reminding everyone, if anybody has any questions, a few questions have come in already. We'll get to as many questions as we can at the end. So there's a myth that the benefits of TDM are impossible to quantify, and therefore the return on investment for a TDM solution is impossible to quantify. And what I want to address this and say it's not easy necessarily to quantify the ROI of a TDM solution, but it is possible, and we've built a model which I'll tell you about in a moment. But let's just talk about ROI in general. So return on investment, key metrics that go into it, to oversimplify it, is you take the total investment, how much money, the cost of everything, the software, the hardware. You quantify the benefits, which we're going to elaborate on in a moment. And if you oversimplify it, that's your return on investment. There are different data points, such as the payback period, the break-even point, when you can actually get to the break-even point, to how much time it takes in order to recoup your investment, and from there on forward, it's a positive return. So before I get into that, I just want to clarify that when you think about the benefits of a test data management solution, you want to be thinking about not just the obvious quality engineering teams, but also software developers who need test data, the data engineers and the like, IT teams that are involved in provisioning data with test data, which we talked about earlier. We just spoke about the data compliance teams, and there's all kinds of people involved in privacy and compliance. And if it's test data automation as part of a CI/CD pipeline, for example, then there will be DevOps teams involved as well. So you want to be looking at the benefits and the people impacted and the processes impacted across, and this is just a partial list of stakeholders. So what are the parameters that you take into account to develop an ROI model? So at K2view, we've built a model, and if you see on the right side of your screen, I believe it is, you'll see a paperclip where you can see attachments. You can download our white paper, which goes through exactly our methodology for building an ROI model for TDM. You're more than welcome to download it and to read it in your spare time and see how it is. And I'm going to summarize the main points over here in terms of how we go about it. So, for example, you want to take into account the number of people before you implement a TDM solution how many people are involved in preparing test data, how many people are involved in discovering and fixing defects, the number of applications that are developed annually, how many are shipped annually, and the cost of hardware and software for storing test data. So that's on one side. On the other side, you want to quantify what kind of benefits and savings you're going to benefit from after implementing a TDM solution. So for that, you want to basically benchmark your before and after. After you've implemented the solution, what is your new test data creation and provisioning cost? And what are your new storage and database costs? And how productive your application development team is. So for example, Daniel mentioned before, we're seeing many teams do a sprint in 2 weeks. The software development team might do a sprint in 2 weeks. Measure how quickly the software application team is developing with test data accessible versus before and after, right? So you want to see how quickly they're producing software, and it's not just the speed, but also the quality. So measure the number of defects along the various stages of the software development lifecycle before and after, and that can be quantifiable. Now, what we did not quantify in our model, though other people may take a stab at quantifying it, and that's perfectly fine, but we went with a very conservative approach, and we did not include certain things like DORA metrics, which has to do with how quickly code is developed and how often it's committed, and how many times you have failures and how quickly you come back from those failures. It also does not quantify a very important aspect regarding the experience of testers and developers waiting for test data. So I think a lot of people on this call can agree and that it's not fun waiting for test data. If you're trying to do your job, whether you're a software engineer, developer, or a QA person, if you need test data and you want to go ahead and do your work, but you cannot because you don't have the right test data, then it's a very frustrating experience. And solving that pain point, according to research, which I'm not going to bring now, it'll just take too much time, but there are research that's showing that a better employee experience leads to better retention. And that's a benefit that's not quantified in this model. Another thing that's not quantified is what could happen if there's a data breach, and also the effect of the savings of carbon emissions and footprint. So the next myth I want to move on to is about data masking. So in my mind, and I've heard people talk about this many times, they think about data masking as this tick box that they need to check when they're looking at test data management tooling. Does it have data masking? Yes or no? But I think this is a very short-sighted way of looking at data masking. There's lots of different data masking methods and techniques. There's static data masking, there's dynamic data masking, role-based access control, but also the different masking algorithms are very diverse. And the traditional way, or the way that some vendors, even to this day, do data masking, is just to null it out, to basically replace PII sensitive data with the word null, and the like. A more sophisticated way is to scramble. If you have, for example, 1 million rows and you have lots of customers, for example, just scramble all the columns so that you don't know which address is relating to which person, and scramble the first names and the last names. That's already a much better technique. But what you want to be looking for when you looking at data masking is also how realistic the data is. So can you take, for example, John Doe and then replace them with a complete data set that looks entirely realistic, even though it's completely fake, and that maintains referential integrity even when you have multiple data sources across systems. And also, you don't want to forget about unstructured data. So correct me if I'm wrong, Daniel, but regulations like GDPR do not say you have to protect customer information, consumer information, sensitive information, only if it's easy to do, only if it's in a structured database and it's easy to take care of it. But if you have, for example, driver's licenses, passports, contracts that are in PDF format, sensitive information, banking information that is in your databases or file systems, there's no reason why you shouldn't take care of that and to address that and mask that data. So that's something to also be aware of when you're thinking about data masking. It's not just the structured data, but also the unstructured data.
Yeah.
Daniel, over to you, please.
Thanks, Amitai. And just to further comment on what you've been saying about data masking, first of all, absolutely true. Compliance mandates make no bones about what kind of data, data it is, or how hard it is to mask it. If you can't protect it, you shouldn't be keeping it, is the general attitude. And going back even further, I think there's, as you say, data masking. I think it's easy to. Data masking is obviously a mature technology, but it's very much not a stagnant one. I think that's the confusion people have. They seem to think they're the same thing, and they very much are not. As on a related note, I also think people tend to downplay the importance of the discovery piece that you talked about briefly there.
Right.
Actually being able to find all the sensitive data you have in your system is really important, and the ways you can do it are actually can vary significantly. But anyway, we don't have time to cover that now.
Yeah, but it's a very good point, because people are always amazed at how much sensitive data they weren't even aware of once they start scanning for it.
Anyway, back to the sort of topic you are going to talk about, which is some of the major trends in test data management in the modern day, which we thought we'd touch on here as a sort of a follow-on from the piece on masking and the previous myth. So this is this is come out of some of our recent research on test data management, which will be soon published in more detail in our forthcoming market update on the space. So if this sort of whets your appetite, then please go to our website at Bloor Research and watch out for that. It should be coming out reasonably soon. But in any case, the trends I wanted to talk about here, the first of which is test data management is effectively on the up. For reasons of largely addressing compliance needs, it is now seen as something of an enterprise requirement, where in several years ago it was seen more as sort of an option, more of a nice to have. That's no really longer the case. Now, I think this is obviously a good thing for the space. I think it's also important not to lose sight of the fact that test data management should also serve to make your testing processes much faster and much easier for your testers. Unfortunately, that can sometimes exist in tension with this need to enable compliance, but that's a tightrope that you need to walk, because I think those are both very important aspects of the technology. The second major trend, which I'll talk about a bit more in a moment, is AI. We've already touched on this, but AI is everywhere in data at the moment, especially generative AI. And test data management is certainly not an exception. The third trend that I wanted to mention is sort of an interesting oxymoron almost, where test data is simultaneously being centralized from a user perspective. This is in terms of things like allowing people to look at and to virtually look at all the data as if it was in a single location, and thereby create their own test data sets and requisition it via self-service. But from an implementation perspective, from a storage perspective, test data is increasingly decentralized. The old sort of model where you had a single center of testing or center of excellence is, while it's not gone, it's much more common to want to decentralize your testing and move it outwards to a bunch of different, to distribute it among a bunch of different testing teams. Hybrid approaches are probably the most common, but we don't see it becoming more centralized from that perspective as much as less as time goes by. We're also seeing increased integration with various DevOps workflows, as well as increased automation for testing and test data in general. Finally, legacy vendors, or at least several legacy vendors, sort of the IBMs and Informaticas and so on, seem to be reducing their investment in test data management space and sort of at least partially stepping away from it and leaving it to, I think, a younger crowd in a lot of ways. People like it. Well, like K2view, not to be a bit too, on the nose about it. And I think it's important, and that makes it really important that if you're going to invest in a test data management product, that you at least strongly consider what the vendor in question will be doing in the next year or two, and ideally take a look at their roadmap to make sure they are actually continuing to support and invest in the space and in the technology. And finally, I promised you I'd talk in a bit more detail on generative AI in the context of test data management, and that's what I'm going to do here. As I say, AI is a massive trend in data at the moment, and generative AI is a key issue for modern enterprise. In testing in particular, and in test data management, it can act as an accelerator and a co-pilot by interfacing with a large language model to let you build and provision your test assets more quickly and more effectively. In particular, this is very useful for synthetic data generation to create data sets which mimic real-world scenarios. You can also feed test data conversely to your LLMs to add context and to add rigor via perhaps a RAG, retrieval augmented generation operation, or use subsetted and masked production data created using test data management to train your machine learning models. In short, there is significant potential which is currently being tapped, but we also feel there's significant potential, perhaps just as much, if not more, which is currently left untapped. And now I will pass you back to Amitai.
Thank you, Daniel. I'm going to run through the next slides fairly quickly because we're running out of time. So I want to cover the myth that modern TDM is data virtualization. And while data virtualization certainly has many virtues, the ability, for example, to spin up environments very quickly, we think that it's most suitable for organizations that have few data sources, fewer dev and QA teams, and very straightforward data environments with popular structured databases. Where data virtualization often becomes a challenge is in complex data environments, where there's lots of different database vendors and versions, including new unstructured databases, and various, data virtualization is a different approach to the traditional test data management approach, which is about subsetting test data for specific test scenarios. There was a question asked earlier, which we didn't get to, but quite Q&A yet, but there was a question about subsetting. So for example, and data reservation, sorry. So how to prevent testers from overwriting each other's data. So the answer to that question is that TDM solutions have the capability of reserving test data for specific testers to prevent that. So with the time we have left, let's quickly just talk about K2view's TDM solution. So we don't really have the time to go into it. And actually, Bloor Research published a whole brief analyzing our solution. We'd be happy to send it to you. Feel free to reach out to myself or to Daniel on LinkedIn or in email or other methods, and we'll be happy to send you that research brief. But in very short, briefly, K2view TDM is able to extract test data from any environment, mask the data on the fly. We talked about also sensitive data discovery, organizes that data by business entities, which we can discuss later, and then subset that data or transform the data and serve it to via self-service portal to testers or via APIs to developers and testers that need it. And there's lots of different functionality available, such as aging the data, various data transformations available besides data masking, lots of different data masking algorithms built in, a topic for another day. And also part of the solution is synthetic data generation. That our solution includes 4 different synthetic data generation techniques, including those that Daniel mentioned earlier. And that's, again, a topic for a different time. But basically, our approach is instead of having one technique to create and generate synthetic data. We offer multiple techniques because there are different use cases, as we mentioned, and there's a different tool that's right for each job. So I'm sorry, we're out of time. We won't be able to cover the questions here online live, but I will follow up afterwards for everybody who asked questions. And I thank Daniel very much for your time. It was a pleasure having you here. And everyone, feel free to check out Bloor Research and to subscribe to their publications. I want to thank everybody from K2view and looking forward to seeing everybody at our next webinar. Bye for now.
Bye, everyone.
Thank you.